What we can do now in nanotechnology is play with things like the equivalent of Lego blocks at a small scale. But not only can we build things with Lego blocks, we also can redesign the Lego blocks so they can do different things.
You're asked to come up with a design or to build something that really hasn't even been built before.
And the closer you look, the more you find. It's almost like an ever-expanding universe as you go smaller and smaller.
I went to the University of Alberta and did an undergraduate degree in engineering physics. I remember going into engineering, and in first year engineering you have to decide what program you're going to go into midway through, and just being really amazed at movements towards miniaturizing devices and microfluidic devices for making Star Trek style tricorders and lab-on-a-chip measurement systems and things for cell phones. I've been focused on trying to develop those next generation devices and figure out how to make those really reliably.
A lot of the projects that we work here, they range over like a really wide span of disciplines, from medical applications to optical to mechanical and automotive.
I was really interested, even as a kid, at making things tiny. Any sort of technology that we have and use in our daily life, you can make it smaller, you can make it more efficient, you can make it do more things when you make it smaller.
One of the projects that I worked on dealt with creating these little tiny microvalves which can be used to control really small volumes of liquids or fluids, and it actually had an application for an automotive company, so you can imagine them making better vehicles using smaller, tinier parts.
I think we're going to change the way we detect and look at the world. Sensors are going to be an important thing about what we can do. We can all of a sudden create things where we can measure 100 different things at the same time.
Well, the phaser is a device to detect different materials based on a signature of light that shines off of that material or through the material. There's an application to look for water on the moon. So to look for water, it has one particular signature, and what NASA did is took a rocket, crashed it into the moon, sent up a plume of debris, including hopefully water, and they looked at the light that passed through there and detected the signature, and they saw the signature of water. So they determined that, yeah, there is water on the moon.
So there's a lot of things where we're just exploring and scratching the surface, and imagination again comes to bear. What can we not do is almost the question.
One of the nice things about a company like Microline is there's a team of about 40 engineers, and we're all on the same team. We're all trying to achieve the same broader goal of being very good at developing these kind of devices for various applications.
I really like that sort of leisure time ability to interact with your coworkers. We play hockey in the wintertime, we play soccer in the field out back in the summertime. Yay!
More exciting is the possibility that we'll be creating things that haven't even yet been thought of or discovered.
A lot of nanotechnology, it's not so much building something as designing a way for a thing to build itself.
It's going to have an impact in consumers' lives, in people's everyday lives. It's going to have an impact in the process of scientific discovery in other fields, and it'll really be an enabling technology in that sense.